Lesson 7.3 is on classifying triangles. All right, now we can classify triangles by a couple different ways. One is to classify a triangle by its angles, and we know in a triangle there are 3 angles in a triangle, right? So based on the angle measures inside the triangle, right, we can identify what that triangle may be. Okay, an acute triangle, that means all 3 angles are under 90 degrees. Okay, they all have to be less than 90 for it to be an acute triangle. Okay, an obtuse triangle, there is one angle measure inside the triangle, so this one right here, that is going to be more than 90 degrees. So if you're looking at a triangle and one angle measure is more than 90 degrees, it's automatically a obtuse triangle. Okay. A right triangle has one angle measure that is exactly 90 degrees. Okay, this box indication or mark here represents that this is a 90-degree angle. So if I have a 90-degree angle, that is automatically a right triangle. Okay, and then if all 3 angles are the exact same measure, all right. Now if there's 180 degrees in a triangle and all 3 of them are the same, that means all 3 of these would have to be 60 degrees. That would be an equal angular triangle. All right. Now that's one way to classify a triangle based on its angles. We can also classify a triangle based on its sides. Okay, so if the side lengths of all 3 sides in this triangle are the same, that is an equilateral triangle. Right? If I only have 2 side lengths that are the same, that is an isosceles triangle. Now these marks are indicating that, hey, this side length and that side length are the same. So it could say maybe this is 10 centimeters and this is 10 centimeters, but if they don't give you an exact distance, the markings indicate, hey, those 2 are congruent or the same. So same thing with those 3, since they all have one marking on them, it means they are all the same. Okay, and on this triangle, okay, here I have a 1 tally mark, 2, and a 3, so that's none of them are the same. Okay, so they do not have the same tally mark, so that's representing, hey, we do not have any sides that are the same. So in a triangle where all 3 sides are different, that is a scalene triangle. Okay, now I kind of mentioned that a little bit earlier, but a triangle has 180 degrees. So the 3 angle measures, all right, that make up the triangle will add up to 180 degrees every time. Okay, all right, so these first 3 examples, all we're going to do is classify the triangle by its angles and by its sides. All right, so we want to give the angle name first, and then we'll give the side name second. Okay, so we're determining what kind of triangle this is based on its angle. So one of those 3, okay, right here. Because of my right angle mark, all right, that is going to classify this as a right triangle. And now we need to also classify it by its sides. Here I have 2 tally marks, so it's indicating that this side and this side are the same. So if I ever have 2 sides the same, that is an isosceles. So this triangle is a right isosceles triangle. Okay, it has 2 names to it, so right isosceles. Okay, middle one, let's classify it by its angles first, right? So these are all under 90 degrees, okay? A 90-degree angle is kind of like an L-shaped angle right here. So all of those are smaller than 90 degrees, okay? So that is going to be an acute triangle because they are all under 90. And I have these tally marks, and they're all 1 tally mark, so it's saying all 3 sides are the same. So if all 3 sides are the same, we have an equilateral. So this is an acute equilateral triangle. All right, last one here. This angle right here, that is opening up more than a right angle, so more than 90 degrees. So that is going to be our obtuse. And I don't have any indication on any of these lines saying that, hey, they're all the same, so I can't assume that, hey, maybe this one looks like that one, the same length. So if I don't have any actual angle measures next to the side, or if I don't have any tally marks saying that this side and this side are the same, okay, we can't assume that any of them are the same. So that would be a scalene. So it's saying that this length is different than that length, which is different than that length. So this is an obtuse scalene triangle. All right? So when you have to classify the triangle, we want it by its angle and by its side. So kind of 2 names on that. All right, the other thing that you're going to have to do is find the value of x. So this is where a triangle has 180 degrees will come into play, okay? So there's going to be obviously 3 angles in a triangle, all right? Those three angles should add up to 180 degrees. Well, here I know that this angle is 65 degrees and this angle is 50 degrees. So what I could do is figure out how many angle measures are already being used up. How many do I already have in this? So I'm gonna take 65 plus 50, and I know that's 115 degrees, okay? So if there's gonna be 180 in this thing, all right, I'm able to take 180 and I'm gonna subtract the two values that I already have when I added them together to figure out what I have left over for my angle X, okay? And when I subtract that, I should get 65 degrees. So this angle is 65 degrees, all right? Last one, okay? Once again, okay, a triangle has 180 degrees, so that's always what we start with. I have a 130 degree angle measure here and a 25 degree angle measure there. So that means I already have 155 degrees between these two angles. So to figure out what I have left over out of my 180, okay, I'm gonna take 180 minus 55 to figure out what's left over here. Okay, and that is 25 degrees. Okay, so if you know two angle measures, just add them up and then subtract from 180 to find the missing angle measure in a triangle. Okay, homework is going to be on page 286. We're going to do 6 through 13 and then number 27.